Hello everyone, my name is Shambhavi and today we are going to discuss about one more function and that function is the linear equation function. Now today we are just going to see that basically how we can just calculate the values for linear equation using our matrix like using the values like using any function. Okay, so today we are just going to see that thing. So for that let me just quickly go to my OneNote and yeah. Here what we are going to see is firstly we are going to see that what is linear equation and basically what's the syntax for using that and all that things, and after that we will quickly move towards the pie chart and write the respective codes for this, right? So let's start with the things. I will just give a heading here as linear and an equation. Okay, I will just write here as linear equation. Okay, so what is a linear equation? We all just know in mathematics that any equation that is of a form of ax plus by plus c is equal to 0, this is called a linear equation, right? So if we are having any equation of a form ax plus by plus c is equal to 0 or ax plus by is equal to c, then it is always called a linear equation. Fine. Let me quickly give you some examples for this linear equation, and basically what I would just take, let's say I just take an equation that is 3x plus 2y is equal to 4. Yeah, this is my linear equation, right? If I just write x plus y is equal to 9, yes, this is also one of my linear equations, because what it is containing, it is basically containing x and y variables that I told that basically a linear equation if is of a form ax plus by plus c. So this is about a linear equation which I have just quickly told you right now. Okay, now what's the syntax? What's the syntax for basically using this in Python? So I would just write here as syntax. Okay, now what we are just going to see. Now I will just let you know that basically how we just write the syntax for that. So here I would just write as numpy dot linalg linear algebra. So as you know that basically these all the functions which you are just covering right now, they all just come inside the linear algebra topic, right? And now this is the third function of this, okay, this linear algebra one. So numpy dot linear algebra, I will just put again a dot here and solve, and here I will just write a comma b. Fine. So the solve is the function which we are just going to use to solve our linear equation right now. Okay, so I just wrote solve a comma b. Now basically what does this a and what does this b means? Okay, so the a are the coefficients values. Okay, coefficient values. And what is my b? B is having my constant values. I will just write here as constant and I will just write here as values. Fine. So a in the place of a, what we are just going to write, we are going to write the coefficient values, and in place of the b, what we are going to write, we are just going to write the constant values. So this was about the syntax of this basically linear equation. Let me quickly just revise that once more. That any equation of a form ax plus by plus c is called a linear equation. I just gave you some examples. 3x plus 2y is equal to 4, x plus y is equal to 9. And then what I just did, I quickly write the syntax, and in syntax I just wrote numpy dot linear algebra dot solve, and inside that solve I just gave two parameters a and b. So what does this a means? This a means the coefficient values and this b means the constant values. Fine. So this was about this solve function. Now let me quickly go to the PyCharm, and here we are just going to write the code for the further procedure. So just let me write here as, firstly what we will basically do, we firstly import the library whichever we are just going to use. So in our case today we are going to use import numpy as np. So what does this line mean? Basically I just tell this thing in the starting of my each and every video. So if you're just following the whole numpy series for like till this time, you must have got a proper idea what does this import numpy as np means. You have this thing has been reminded to you, stuck in your mind very in the form that you will never forget it. Okay, so import numpy as np. Now what does this mean? So numpy is my library which I am using. So basically there are some libraries which are not installed in your IDEs which you are using, so you need to install those libraries. So I just install that numpy library, and after installing you can only import the library. So I just wrote import numpy. Now what is this np? This np is basically giving a shortcut to my numpy library which I am basically using. So I have just written import numpy as np. Right, now let me quickly, okay, let's find out that can we just write that and use this help function with this thing. Okay, just let me put the bracket, and I would just write here as np dot lin lin alg. I would just write here as solve. Okay. So now I will just run my program. Fine. Okay. So here what just I got that basically what might the solve function do. So I just got the whole idea about my solve function. Let's quickly go and see that basically what does it do. So here it is written solve a comma b, solve a linear matrix equation or solve a system of linear scalar equation. So what does the solve function do is basically solve a linear metric equation or system of linear scalar equation. So this is the work for basically the solve function. Now what next we have. So here it is written that computes the exact solution x for the well-determined, that is full rank linear matrix. That's fine. Let's quickly move towards the parameter and see that what are the parameters. So I just told that a and b. Now what is this? A is the coefficient, and what is this? B? B is a dependent variable. You can just call it as a constant ones. Fine. And what does it basically returns? So it basically returns me an ND array. So these are the other things which you can just refer on your own. I'm not going to take these things. So here this was the example, and now we are just going to see the example on our own. Fine. I will just comment this line here itself. Fine. Now what I'm just going to use, I'm just going to take a variable that is a. What I'm going to use, I'm just going to assign it a matrix. So np dot array and brackets, I will just write here as 4 comma 2 and 4 comma 2, and even I would just write 1 comma 3. Let's say. Fine. So this is the basically thing which I'm just using here. Now what I would do, I would just go to my next line. Here what I would just write, I would just write b is equal to np dot array. So here in the first what I have taken 4 comma 2 and 1 comma 3. So a is equal to np dot array 4 comma 2 comma 1 comma 3. Right. So this was one of my square matrix which I have taken, and that was of a 2 cross 2 matrix. Now what I have next, so b is equal to np dot array. Now here what I would just write, I would just write some value. Let's say I just wrote 6 comma 7. Now what does the 6 comma 7 means? So if I'm just going to take this in the form of ax plus by forms, and then what it will be, so just listen to my words, I'm not going to write that thing. So it would be 4x plus 2y is equal to 6 and 1x plus 3y is equal to 7. So these are the basically the values for x and y, the coefficients for x and y, and these 6 and 7, what are basically these are the coefficient constant values which we have. Fine. So here I have just written now what else I would do? I will just write c is equal to np dot linalg linear algebra. I will just write solve, and inside the solve I would just write here as a comma b. And now what I would just write, I would just print my c. So I will just run my program. Fine. Okay. So here what I just got the solution for this linear equation, and here it is showing that the solution for your linear equation is 0.4 and 2.2. So now I'm not going to verify these things. You can just verify it on your own. Basically you all know that what are the ways for solving the linear equations, right? So we just substitute sometime, and even we can just take some common, or we can just do all that things. You all know. So I'm not going to show that mathematics thing here. So this was the way for solving the linear equation. Let's say I just take one more example. I would just comment all of these things because I'm going to take the same variables right now also. So I would just comment and yeah, fine. Let's move to, I would just take x is equal to, and I would just write np dot array, and what I would just write inside this brackets, let's say I just gonna take 3 values. I would just write 4 comma 1 comma 3. I would just put 1 comma, and then I would just write 7 comma 9 comma 2. I would again put a comma. I would just write 4 comma 6 comma 1. Let's say these are the values equation which I have taken. These are the 3 equations, right? Above what we have seen the examples for the two quadratic 2 linear equations. Now here I am just going to demonstrate the example for the 3 linear equations. So x is equal to np dot array, and I have just stored this matrix inside this, and this would be treated in the form of ax plus by plus c format only. And what I would just write, I would just take another variable, and that is y. I would just write equal to, and I would just write here array and the bracket, and inside this I would just write some coefficients for this. I would just write 2 comma and I will just write 4. Okay. So what does, okay, np dot array, fine, np dot array I will just need to remove this a, and I will just need to add this a here. Fine. Now what I would do, I would just write print. Okay, after writing this print, what I would, no, not print, I would just firstly take another variable, that is z. Now here I would just use that solve function, right? Z is equal to np dot linalg, that is linear algebra dot solve, and I would just, okay, 1 o, and then inside the bracket, what I'm gonna give the values, like variable that are x comma y. And next what I need to do is the last step, I need to just print the z, in which basically I'm storing my output. So I will just run that program, and after running that, see, now here what did I just got? I just got the output. Some are in negative and some are in positive, so that things do not matter, right? Because like we are just going to give the get the values for the linear equations whatever we have used. So it is minus 10 and it is 5 point something, it is 12 point something. So this was the like demonstration for this, you can say 2 cross 2, sorry, like you can say 2 linear equations. So here what I was having 3 linear equations. So you can just take these things to 4 or 5, whatever linear equations you just want to calculate. You can just add the, and like write the things here itself in the program. You can just calculate the roots of the equations very easily, right? So this was the way for basically how you can just do the things and how you can just calculate the linear equations, and you can just calculate the roots of the linear equation using the Python program. So this was basically syntax, that was np.linalg.solve. And if you just want to like gain some more knowledge about the solve function, so what you can do, like you can use this help, and inside this help just write the statement, that is np.linalg, that's linear algebra dot solve. So when you just run the program, you will just get the whole information, that what is written, what are some more examples in this, and what are the parameters, and all of that things you can just have a look over that, right? So this is all for this video. Till then, thank you and bye bye.